Welcome to Nova Videos. In this video, I'm going to illustrate how to use the My Commands option to create customized data analysis commands. Welcome to the Nova software. This video illustrates how to use the My Commands option to create customized data analysis commands. The Smooth tool will be used to smooth the data provided by the cyclic voltammetry potentiostatic measurement. The derivative analysis tool will then be used to calculate the first derivative of the smoothed data. To illustrate this case study, the default Autolab cyclic voltammetry potentiostatic procedure will be used on dummy cell A. To smooth the data displayed in the I versus E plot, select the Smooth Analysis tool from the microscope in the upper menu. Well, first we have to load the default procedure cyclic voltammetry potentiostatic. Like this. In the CV part, we can do already the analysis, like add analysis command. We can smooth by selecting the smooth option in I versus E. In the smooth function has the following parameters. Command name, smooth, you can modify this accordingly. The mode, Savatsky Golay or FFT. Spike rejection, it enables a special filter that precisely precedes the Savatsky Golay filter, eliminating spikes. Polynomial order defines the polynomial order of the polynomial function fitted through the data. A small order leads to a heavy smoothing. And the smooth level specifies the Savatsky Golay filtering level, configuring the number of points in the averaging window. The level is selected from a drop-down menu. Well, for this example, a smooth level of 3 will be used. Switch to level 3. Using the drop-down list for the corresponding parameter. We can give it a red color. Like this. So it will be plotted in plot number 2 and the CV will be plotted in plot number 1. The next step requires the calculation of the first derivative of the smoothed data. To calculate the derivative of the data provided by the Smooth Analysis tool, select the Smooth icon and press on the microscope in the upper right corner. Select the Derivative Analysis tool from the menu. A new item called Derivative will be added to the data. The first derivative of the smoothed data will automatically be calculated and the derivative plot will be added to the Derivative Analysis tool. So now we've set up the experiment. Now we have to create some noisy data. Well, I'm going to scan a little bit faster and I increase a little bit the step size. Also, I'm going to, in the options, I'm going to use a higher current range. Now the procedure is finished for measurement. So I can run the procedure. It's just a CV of on a dummy cell. And the first measurement is the noisy data. And the second plot is my smoothed function. And the third plot is my derivative. The data is available. When I change the level of my smoothing level, I can see also a change of the derivative directly. If you want to use this function in the next step, you can save it as My Command. We can do that by selecting the floppy, so this one, I want to save this specific CV staircase as my own command. At the moment, there is no my command available, so I have to create one. This is done by this button here, save command to my commands. When I do this, okay, CV staircase, width, smooth, and derivative. Press OK, and then it will be stored underneath here, under my commands. And when you go to the icon, you will see the file name CV staircase with smooth and derivative. So you automatically made a analysis tool which you can use for your next experiment. For example, if you start a complete new procedure, for example, a new procedure, you can just use that command and use that command for your next measurement. And this will do automatically all the analysis which you've done previously. So once you've defined your analysis in a command, it always can be used for the future. Thank you for watching Nova videos. If you found this Nova video helpful, like and share with your colleagues. Please subscribe to the Metrohm Autolab YouTube channel so you are notified when new videos are available.